So good morning, good afternoon, or good evening to everyone. My name is Marlan Pillay from the UN Climate Change Secretariat. On behalf of GIZ and UNFCCC, welcome all of you to today's webinar. This is the last of the series of webinars covering the chapters of the document titled The Compendium of GHG Baselines and Monitoring, Passenger and Freight Transport. This document was prepared by the Deutsche Gesellschaft für internationale Zusammenarbeit, GIZ, in cooperation with the Climate Change Secretariat, and with the Partnership for Low Carbon Transport and the Federal Ministry for Environment, Nature Conservation, Buildings and Nuclear Safety of Germany. Many others have assisted in writing this document, such as the Center for Clean Air Policy and the International Council on Clean Transportation. So if you would like to access other webinars in this series, please visit Changing Transport webpage. The link is provided on this slide. You will all receive this presentation at the end of the webinar. The webinar today is approximately 60 minutes. We have a short welcome and introduction to Chapter 1 of the Compendium on Mass Transit Investments. Thereafter, we will share with you a few project-level mitigation actions. We describe these mitigation actions and their baseline scenarios and project scenarios using methodologies from the Clean Development Mechanism. Thereafter, we will open the floor to accept questions from the audience. We urge you to send in your questions through the chat feature of the WebEx system. Before we continue, may I please request everyone to check that their microphones are muted. Okay. So thank you, and let's begin. Okay. My name is Marlan Pillay. I am your moderator for today. I joined the Climate Change Secretariat in 2010 and have worked in various areas on the CDM, JI, and now in the role of supporting developing countries to enhance the capacity to meet reporting commitments under the Climate Change Convention and the Paris Agreement. I would now like to hand over to both my colleagues, Mr. Badve and Mr. Cardoso Filho, to introduce themselves.
Hello, good morning, good evening, or good afternoon, wherever based on your location. My name is Vikrant Badve. I'm an energy and environment professional with around 15 years experience with the private sector and UN organizations. And that includes the experience in development, implementation, and monitoring of climate change mitigation projects in energy and transport sector in Asia and in Africa. The other experience also includes drafting the regulatory documents such as GHG emission reduction methodologies and the methodological procedures. I'll be happy to share today with you about the transport methodologies in MRTS sector. Thank you. So.
Hello, good morning, good evening, good afternoon. My name is Eduardo Cardoso, Filho. I'm from Brazil. I've been working with CDM related projects and methodologies since 2005, first as a project developer in Brazil, attending Latin America. And since 2009, I've been working with the UNFCCC Secretariat, initially with the project assessments, assessing the request for registration, issuance, renewal of crediting period, etc. And since 2016, I've been working with the development of CDM methodologies and GHG accounting standards, specifically to the transport sector and to the energy efficiency sector.
So thank you, Vikrant and Eduardo. So let's start with an introduction to Chapter 1 of the Compendium, Mass Transit Investments. So we will start with a short overview of Chapter 1. So you will see from this slide This chapter covers project level investments that create or extend specific mass transit passenger transport infrastructure in a region. And this includes, for example, bus rapid transit systems, trams, metros, and cable cars. So the subheadings on your screen show how the chapter evolves from describing the characteristics of mass transit investments to understanding the mitigation effects, and then tools to help you select mitigation actions that are appropriate to your context, and then including how implemented mitigation actions are monitored to ensure it delivers on the estimated emission reductions. And of course, we end with an example, and in this case, the Columbia Trans-Millennial project. So this slide provides a useful overview of the mass transit investments causal chain. So it describes two key types of actions. The first is in a new mass transit infrastructure, and the second is the update mass transit vehicles. So the first seeks to cause a modal shift from the use of private vehicles, taxis, minibuses to public transport. And the second seeks to improve the fuel efficiency, either by updated public transport vehicles or by reducing congestion. Therefore, you will see that information about the trips, the vehicles, and emissions need to be monitored to indicate how reductions in GHG emissions result from these type of mitigation actions. And of course, these projects are defined by the boundaries that they have. And these boundaries have different dimensions to it. So the boundary depends on the size of the project and the availability of data. For example, the larger the geographical area, the more interaction and temporal effects can be analyzed. However, this will require greater data collection, then impacts on the cost of obtaining that data. So methodologies therefore help us to set the dimensions of the boundary, since they are based on the scientific understanding and expert judgment on these dimensions. And that then helps you to set the boundary for your projects in this mass transit investment mitigation actions. Okay, now when taking mitigation actions in this field, one of the key aspects to take note of is any concerns about double counting. This slide is just to bring to your awareness that other policies and actions taken to mitigate GHG emissions have synergistic or interaction effects on the mass transit mitigation action. So care should be taken in this regard. So this slide helps you to navigate the classes of available methods and associated tools for mass transit investment mitigation actions. Baseline scenario for mass transit investments is based on the current travel data, which is then projected into the future for ex-ante analysis and counterfactually projected for ex-post analysis. There are three general approaches used for projecting travel activity data, and these are the use of the travel demand models and expert judgments. So these projections then allow us to estimate the emission reductions from the difference between the project emissions and the baseline, applying suitable methodologies. So this slide describes how you would go about selecting available tools and methodologies according to the purpose and level of accuracy. And of course, depends on the level of disaggregated data that is available. For example, for a variable like travel activity data, if data on the total vehicle trips could be collected specifically in the boundary area and by the vehicle type, this could be move the selection of available data from using defaults to local data, thereby improving the accuracy. So we are missing a slide, which I'd like to just call up. So slide. Yeah. So coming back to the general approaches, these are the general approaches that are used. One, the travel demand models, which is generally used for ex-ante analysis. The travel activity survey, which is ex-post analysis, which is usually done with MRT projects. And expert judgment, which is based on historical trends during time series data that is gathered ideally for at least 10 years. Okay, and so these are this is the table of travel demand models for mass transit investment mitigation actions. So you will see this table is here to help guide you, looking at the cost of the tool, the methodology, documentation, and the data collection guidance. So it helps you select tools that would apply to the type of mass transit project that you are intending to invest in. So, of course, performance of mitigation actions can be monitored by tracking key variables over time. So information on implementation and performance should be included in the monitoring plan to show progress before the full effects of the action may be apparent. So this table provides a list of variables that could be monitored, including the frequency of monitoring that is needed. So you will see these incorporated in CDM methodologies, which we are going to show you today. So this is a very brief overview of chapter 1 of the compendium. And I encourage you to look at this chapter in greater detail, where there are other tables and figures that you may find helpful. And now we are going to move on to examples of monitoring these types of mitigation actions. I would now like to hand over the floor to Vikrant to take us through the CDM methodologies that are available for mass transit projects. So thank you very much for your attention so far.
Thank you, Marlan. And as Marlan mentioned, let's go through some examples of CDM methodologies for transport sector, specifically for mass rapid transit projects. And let me start with the little background in the transport sector. In the CDM, so we have under CDM 21 approved methodologies, 5 in the modal shift in passenger transport, 2 in the freight transport modal shift, 5 again in the energy efficiency measures, 3 methodologies in the production and use of biodiesel for transport, 4 methodologies in fuel switching and electric or hybrid vehicles, 2 methodologies for aviation related methodologies. And these methodologies are assisted by 3 methodological tools which are being used to determine the baseline emissions from different options. In terms of the project, there are 38 project activities which are registered under CDM. Out of that, 33 are CDM project activities and 5 are CDM program of activities, which can be then joined with the several CPAs. In terms of sector within the transport, 24 projects and 1 POA was registered under MRTS or BRT sector, or that uses cable car as a project. 6 projects and 1 POA was registered that involves fuel switching measures. 2 projects got registered with the production and use of biodiesel. 2 program of activities are registered which applies introduction of low GHG emitting vehicles, and 1 project and 1 POA was registered with the modal shift in freight transport, that is shifting from road to rail measure. So let's focus on the MRTS methodologies, as the sector and the chapter is more talking about the investments in the mass rapid transit systems. There are 3 methodologies under CDM that can be used or applied for the projects under MRTS. AM0031 for bus rapid transit projects, ACM0016 for mass rapid transit projects, AMS3U for cable cars for mass rapid transit project systems. Let me then take you through the detail of each of these methodologies with one example from each of the project, example from each of the methodology, and present you some key challenges in together. Let's start with AM0031. As you see here, you can see on screen the methodology includes typical projects such as new bus rapid transit project systems for urban transportation. That includes replacement, extension or expansion of existing bus rapid transit systems, that is adding new routes and lines. Baseline scenario here is the passengers being transported using a conventional transport system, that is buses, trains, private cars or non-motorized transport modes. In the project scenario, the passengers will be transported using bus rapid transit system. If you see on the right hand side in the screen, you will see the pictorial diagram for which describes the baseline scenario and the project scenario. Relevant applicability conditions for these type of projects under CDM is a new BRT system with a feeder and trunk route is applicable. That methodology is not applicable for inter-urban transport, and it's not applicable for operational improvements, that is new or larger trains or buses. Next slide. Next slide talks about the baseline emissions, determination of baseline emissions or project emissions from application of this methodology. So baseline emissions here would be that would have taken place if the passengers have used the conventional transport system. The major parameter in the determination of baseline emissions is the emission factor, baseline emission factor per passenger kilometer for the transport mode, the share of passengers who shifted to the project system, the average trip distance, and the improvement in the technology factor. Project emissions here comprises of the project system emissions due to the project system. That includes the project trips. And there are two alternatives being available here in the methodology for calculation. First is the use of fossil fuel consumption data, and the other one use the specific fuel consumption and distance data. Both of these options need an important parameter to determine, which is the emission factor, which is derived based on the fuel efficiency data, that is the consumption per kilometer of the driven project system. Followed by the project emissions, the methodology also considers the leakage due to changes in the load factor of taxis and buses of the baseline transport system. It includes reduced congestion on the affected roads, provoking higher average vehicle speed, plus rebound effect and upstream emissions of the gaseous fuels. Let's then move to some of the important parameters that needs to be monitored or fixed ex ante. First, with the parameters that are fixed ex ante at the project registration phase, is the baseline distance traveled and the transport mode used by passengers using project system. The occupancy rate of the baseline vehicles, while the monitor parameter includes the total number of passengers transported by the project system, specific fuel consumption of the project vehicles, number of buses in the conventional system, average distance traveled by the passengers in the project system, occupancy rate of the project vehicles, speed of cars and taxis on affected roads during the crediting period, buses retired as a result of the project, and share of the passengers using the transport system which would have used another transport mode in absence of the project. The one which are highlighted in the red color are the parameters determined based on survey. A fixed parameter shall be determined using survey at the time of project registration, while those monitored needs to be surveyed during the first and fourth year of the crediting period. Let's then move to one of the example for using AM31. There are total 11 projects which are registered using AM31 methodology, and out of these 11 projects, 5 projects have issued around 853,000 CRs during the KP1 period, which is up to 2012. And after 2012, there are 2 projects which has issued around 141,000 CRs. Take an example from one of these projects. The project is from China, which is Lanzhou Bus Rapid Transit Project. The project aims to meet the growing demand for public transport in Lanzhou by establishing BRT system in one of its districts. The project consists of a new infrastructure of 12.3 kilometers of dedicated BRT bus lanes, flexible operation making allowance for both specialized BRT buses and existing buses. The methodology applies version 3.1 of the methodology. Host country is China, and the estimated amount of emission reductions per year is around 12,621. The results from the latest issuance from the project has shown that the emission factor per passenger transported of cars is 710 grams CO2 per passenger. Emission factor for per passenger transported of taxis is 1008 gram CO2 per passenger, and that of the motorcycles is 160 gram CO2 per passenger, while that of the transported buses is 288 gram CO2 per passenger. And the total number of passengers being transported is around 21 million from this project. Let's then quickly move to the next methodology under transport, which is ACN 16 Mass Rapid Transit Project. As like the previous methodology, ACN 16 also has the typical projects which are more on the rail-based or bus-based mass rapid transit system, while AM31 was very specific for the bus transit system. ACN 16 is more open for rail and bus-based transit systems in urban and suburban regions for passenger transport. The baseline scenario here is the same, the passengers transported using conventional transport system, and the project scenario where the passengers will be transported using rail or segregated bus lanes. Relevant applicability conditions also includes the railways or segregated bus lanes in order to replace the existing bus routes. This methodology also not applicable for interurban transport, not applicable for operational improvements. You can see the pictorial diagram for the baseline scenario and project scenario that simplifies the understanding of the kind of projects this methodology will cover. Moving to the next slide about the baseline emissions and the project emissions. The baseline emissions here will again come from the transport modes which passengers would took in absence of the project. That includes the parameters like passengers, number of passengers transported by the project, number of passengers being surveyed, and the baseline trip distances, including multiplied by the important parameter baseline emission factor per passenger kilometer for the mode of transport. That is determined based on the survey. Project emissions, again, from this methodology will come from the operation of the project, which has direct emissions plus the emissions that are caused by the project passengers from their trip origin to the entry station of the project and from the exit station to their final destination. So it involves both direct and indirect emissions. Details about it are mentioned there on the slide, or you can also refer to the methodology for further details in terms of formula. Leakage, again, this methodology also take care of leakage due to the change in the load factor of taxis and buses, the reduced congestion on affected roads, and upstream emissions of the gaseous fuels. Moving to the important parameters that needs to be monitored. Similar to AM31, the methodology also needs to monitor baseline distance traveled and the transport mode used by the passengers that are now using project system, occupancy rate of the baseline vehicles, and the monitor parameters includes total number of passengers transported by the project system, specific fuel consumption of the project vehicles, number of buses in the conventional system, average distance traveled by the passengers in the project system, occupancy rate of the project vehicles, speed of cars and taxis on affected roads during the crediting period, number of bus units or the units retired as a result if it is a MRTS includes the BRT project, and the share of passengers using the transport system which would have used another transport mode in absence of the project activity. Again, the parameters highlighted in red need to be determined using survey. The fixed parameter needs to be determined at the time of project registration, while the one monitored needs to be surveyed based on at the first and fourth year of the crediting period. Taking one example from ACM 16, before moving to that, let me mention you that there are 12 projects which are registered applying this methodology under CDM. And out of the 12, 3 projects are BRT-based transport system and the 9 are rail-based metro transport systems. Out of these 12 projects, 3 projects have issued CR under KP1 period, that is up to 2012, and that amounts around 381,000 CRs. While in the KP2 period, after 2012, there are 3 projects which came for regular issuance and the amount is around 2 million CRs. And major share is from the project in Delhi, which I will just describe you in brief. This project involves the establishment of modern MRTS system that is partially elevated or partially underground, and it is of the length of 102 kilometers, expecting to transport on an average around 1.1 million passengers as estimated in 2011. The project applies version 4 of the methodology hosted in Delhi, India. Amount of emission reductions are estimated are 529,000 CRs per year. The main features of the project as per the recent monitoring report been submitted is the emission factor per ppm of the car is 91 gram CO2 per ppm. For the taxis is 156 gram CO2 per ppm. For rickshaws, the tricycles is 63 grams CO2 pkm. For motorcycles, it is 26 grams CO2 pkm, and for buses, it is 23 grams CO2 per pkm, and for the suburban rail system, it is 41 grams CO2 pkm. As per the recent monitoring report, the project has transported around 285 million passengers during the crediting period. Quickly then moving to the third methodology on AMS 3U, which deals with the cable car system for mass rapid transit systems in the urban area. Typical projects involves the use of cable cars for the urban passenger transport, and basically more suitable for the cities having hilly terrain. Baseline scenario involves, as in the earlier methodologies, the passengers been transported using conventional transport system, and the project scenario involves passenger being transported using cable cars. Pictorial diagram indicates very clear understanding of the type of project activity that's been involved here, and the applicability condition includes the origin and final destination of the cable car should be accessible by the road, and the project methodology is not applicable for an extension of an existing cable car system. Moving then with the baseline emissions and the project emissions. The baseline emissions here includes the emissions that would have taken place in case the passengers were transported by the conventional modes, and that includes the important parameters as baseline emission factor per passenger kilometer of the transport mode, average trip distance, number of passengers transported by the project system, and the trip distance, obviously. Emission factor, as usual, will be determined based on the survey. The project emissions, similar to ACM 16 methodology, includes direct emissions and indirect emissions. That includes the emissions caused by the project passengers from their trip origin to their entry at the entry station and from their exit station to their final destination. Moving to the leakage part, being a small-scale methodology. This methodology includes leakage only when total annual effect is to reduce estimated emission reductions. Then the significant change in the average occupancy rate of each vehicle category is considered as leakage, and significant here means 10% or more. Impact of inbound traffic provoked due to the project system is addressed as an indirect project emissions. So little simplified approach compared to the other two methodologies, which is used for the large scale projects. Then moving with the parameters that need to be monitored, specific fuel consumption of baseline vehicles, occupancy rate, and total number of passengers transported by the baseline transport system will be fixed, while the monitored parameters includes the total number of passengers transported by the project system, electricity consumption by the cable car system, share of the passengers in the quarter S of year Y, and these passengers would have taken the baseline transport system, share of passengers in the quarter S of year Y who have been using the project system, average distance traveled by the passengers in the project system, and occupancy rate of the project vehicles. As mentioned earlier, the parameters mentioned in the red color need to be determined using survey, which needs to be conducted at the first and fourth year of the crediting period. So then moving to the applicability condition for the three tools. I think I'm just missed with the slide. Let's go first with one of the example for the cable car project in Metro Medellin in Colombia. The project involves the establishment of cable car based MRTS system, and that is an integral part of the metro system of Medellin. with a prepay fare system. This project applies version 1 of the methodology, and estimated CRs is around 17,290. This is the project which came for recent issuance submission, and which has the specific fuel consumption of taxis is 56 gram per kilometer. For gasoline taxis, it is 57 gram per kilometer. For passenger cars, it is 63 gram per kilometer, and motorcycles is 18 gram, while for medium size buses is 23 gram per kilometer, and for small buses is 160 gram per kilometer. The total number of passengers transported, as mentioned in the recent monitoring report, is 112 million passengers, and this is the only project which is coming for issuance in the KP1 and KP2 period. It has already issued 22,000 CRs in the KP1 period, and in the KP2 it has issued 46,000 CRs. There is another project activity which is registered with one CPA applying this methodology, but that has not come for issuance as yet. So then moving to the review of the tool, basically, which has been used for the MRTS project to determine the baseline emissions for model shift. The tool is used in conjunction with one of these methodologies depending on your project type, and the applicability of the tool is to develop a standardized baseline or to calculate baseline emissions from the transport projects, implementing modal shift measures in the urban transport project. Stepwise approach provides determine the vehicle categories. It has already mentioned few vehicle categories within the tool, and based on that, then to determine specific CO2 emissions per kilometer traveled for each vehicle category, and based on that to determine the emission factor per passenger kilometer for fossil fuel and electric vehicles. For electric vehicles, electricity consumed, passenger transported, and distance travel need to be monitored, while for road-based vehicles or the occupancy rate of buses, taxis, or cars, specific CO2 emission per kilometer travel for buses, cars, and taxis need to be monitored on the point. And then, based on all these data, the baseline emissions based on the total number of passengers transported per kilometer, the total number of passengers transported and emission factor passenger per kilometer, average trip distance traveled by passengers, and share of passengers who shifted from electricity-based or fossil fuel-based vehicle to the project mode will be then calculated based on that. Let me then move to some key challenges while applying these methodologies together with the tool. One of the key challenges in the baseline assessment is to have the data about the share of baseline transport modes in the urban public traffic scenario and the occupancy rate of the baseline transport modes. In terms of monitoring, it has key challenges includes one of the point on the survey requirement. These methodologies need extensive survey requirements which need to be conducted for the first and fourth year of the crediting period to determine important parameters such as share of passengers in the transport mode and their distances traveled. In terms of performance indicator, the methodologies need to know the number of passengers using project system, traffic congestion in terms of AM31 and ACM16 methodologies, and occupancy rate of the project system. In terms of impact indicator, the emission factor per passenger kilometer of various transport mode needs to be monitored in the project scenarios. So these are the key challenges depending on the situation, because most of the information needs to be also taken from the regulatory authorities or the project-based surveys. That is additional to something the normal transport project does. That's the end for the review of CDM methodologies for MRTS project. If you are keen to know further or want to find out where the methodologies are, you can refer to the screenshot and then find out a methodology under large-scale project activity and a small-scale project activity. The screenshot provides you the information, or you can also click the link provided on the screen. So that's the end for the webinar for these presentations. And if you have any questions, we'll be very happy. You can mention your questions as mentioned earlier by Marlan in the chat box. Yeah, thanks.
So thank you, Vikrant, for taking us through some of the CDM methodologies associated with this mass transit investments projects. Right? As you can see from Vikrant's presentation, a number of variables need to be monitored for mass transit projects. These are essential to ensure that the estimates of greenhouse gas emission reductions are reliably determined, but also to understand the interaction effects and other effects. So for example, a modal shift from private vehicles to more fuel efficient public transport could result in an increase in the number of trips using the new public transport system, which then impacts on the emission reductions that can be achieved. Therefore, Chapter 1 is there to help you to navigate your way as you decide what mitigation actions in the mass transit field you would like to take. And it is important that these types of mitigation actions are seen within a context of a broader long-term policy or strategy. So to transform the mass transit system in order to validate the associated cost for implementation and for monitoring of these mitigation actions. So we have not received many questions. But I would like to hand over to Eduardo, who is chairing the Q&A session. Eduardo, the floor is yours.
Thank you, Marlan. Perhaps we can leave some 5 minutes for participants to elaborate their questions, and we can answer them on demand. Okay? Okay, I have here the first question for Vikrant. Which are the trends expected for the transport sector and how they can be improved and taken into account? Please, Vikrant.
Yeah, so in terms of the trends, I think more on the transport side, as you see, more and more projects cities are being now facing the issues related to traffic congestion, and the authorities are now been getting more on providing efficient transport in the cities. So as we see, although cities consider only 3% of the total population, total emissions on the point, but transport considers much more part of the emissions, and authorities are now going for more transport friendly projects such as MRTS or metro system projects, BRTs projects. Maybe that's a city maybe in Latin America or Africa or in Asia. I think these authorities are more interested to provide seamless transport connections. That is one of the key points for its residents and the investors in terms of providing easy access to the transport points. And with these things, most of the financing institutions also have started more with the support on providing funding to the city authorities or the country authorities on developing the efficient and easy transport modes. Adding on that point, basically, I feel there is an immense need of providing efficient transport, not to avoid I mean, it will not just only avoid the congestion, but it will also provide a pleasant experience for transporting within the cities and commuting for its residents or visitors in a way. And there I feel there is a connection. If the project needs to be monitored as one of the mitigation action, then there is a need for monitoring. And there comes the help from these one of these methodologies, which can then help the authorities or the project implementing agency to quantify the emission reductions and claim these emissions in the new market scenario or under new regime of Paris Agreement. Yeah, thanks.
Okay, so we we have one question about the types of surveys that are used in some of these CDM methodologies, and I would ask Eduardo if he could say a few words about that. Thank you.
Okay, thanks, Marlan. Indeed, survey is the most time and resource consuming component of CDM methodologies. And it happens because you can't measure the behavior of the user of the public transportation system. It's not like forecasting the electricity generation by a power plant. And for CDM, you can see from Vikrant's presentation that the leakage component may have a very important impact in terms of rebound effect and road space available for additional trips, etc. So in order to safeguard the environmental integrity, the requirements for CDM to conduct the surveys and to account for these side effects, they have to be considered. The methodology, they have thorough guidance on how to conduct the surveys, very detailed guidelines on the frequency, on developing the questionnaire, on how to stop the passengers to ask the questions, making the interviews, etc. And to date, methodologies only allow the survey to be conducted in years 1 and 4 of the crediting period, which is already some flexibility provided by the CDM Executive Board, because the original versions required the yearly surveys being conducted yearly, which were not feasible for projects given all the time and financial issues related to developing the questionnaire, developing the sampling plan, putting in place the interviews, and then analyzing the data to reach the information requested. So yes, it has to be conducted. We have some flexibility nowadays. We know that it's complicated, it's not easy, but that's what provides the environmental, that safeguards the environmental integrity for the CDM and for the transport sectors applying the CDM methodologies.
So thank you, Eduardo. So indeed, yes, surveys is an important component of these type of mass transit mitigation actions, and it is the CDM methodologies provide some really good guidance on how to conduct surveys to obtain the level of disaggregated data that is required to do the estimations of emission reductions from these projects. So indeed, thank you, Eduardo, for giving us information of that. And I would like to also thank Vikrant for his presentation on the CDM methodologies. I hope that this short webinar has been of some benefit to you in navigating how to use Chapter 1 of the Compendium for passenger and freight transport. And I hope that you would join us in future for webinars and workshops as we proceed to create more awareness and share knowledge about achieving emission reductions in the transport sector. So thank you everyone for joining. We wish you a good day and see you next time.
Yes. Thank you all for joining the webinar, and we look forward to have receiving you again on the future webinars. And if you have any questions on this webinar, please feel free to share that with us through emails. Yeah. Thank you. Thanks.
Okay, thanks everyone, and hope you have a nice day, evening or afternoon. Thanks for participating, and as Vikrant said, if you have any questions, you can see the contact details on the screen. Just feel free to get in touch with us.
And we will be sharing the presentation, and together with that, a short survey to get your feedback on this webinar. Thank you and goodbye.